All right, welcome back to Ingenuity. This is Algebra 2A. We're going to be talking about geometric series. So let's get started. So these are the first thing I want to talk about is the sequence. If you hear geometric sequence, basically you're going to be having numbers separated by common ratios. So I'm just enlarge the example over here. So you can see that there's going to be a common ratio of multiply by 5, multiply by 5, multiply by 5. Okay, um, so the sequence is going to keep going without ending. And then so here's the equation for a geometric sequence. But here we're going to be talking about series. So series is the only difference between series and the sequences. If I have a geometric sequence and I add all the terms up, so next one I'm going to add 25, I'm going to add 125. The adding and combine all the numbers in the sequence, we're going to call it the series. Okay, so let's get started for the first question. So what is the value of a sub 1? Okay, so a sub 1 is the first number, and the ratio is going to be, so you multiply by 3, you multiply by 3, multiply by 3 to get to the next term. Okay, so a sub 1 is 1, and then ratio is 3. All right, so what are the values of a1? So we already know that a1 is the first number. Okay, that eliminates the second and third. And then from one number to the next, you gotta have to multiply by -1, multiply by -1, multiply by -1. Okay, so -1 is your r. So what is the value of r of the geometric series? So it looks complicated. You got that sigma notation over there. Okay, all you need to know is that it's going to be right here. This is your r. So there's no calculation. Okay, so what is the value of a sub 1? So basically, in order to find out a sub 1, you just have to sub n equals to 1 into this expression. Okay, so this is what I'm going to do. So you're going to have 12 times -1/9 to the 1 minus 1. Okay, because I subbing n equals to 1 into this n. So 1 subbing to the n. So you got 1 minus 1, which is going to be 0. And anything to the 0th power is going to be 1. So it's going to be 12 times 1, which equals to 12. All right, so which equation represents the partial sum? Okay, so this is what you need to do. So you're going to sub in 1 in there. So 125 times 1/5 of 1 minus 1. 125 times 1/5. Now we're going to sub in 2 into n, so 2 minus 1. 125 times 1/5, 3 minus 1. And we're just going to keep going. Okay, the n value is going to go up by 1 every time. Okay, so let's see what we got. So we have 0 over here. We got 1 over here. We got 2 over here. And we got 3 over here. Okay, so that gives you 125 times 1, which is 125. This is 125 times 1/5, so that's 25. So this is 125 times 1 over 25, so it's going to be 5. The last one is going to be 125 times 1 over 125, so this is going to be 1. Okay, so that is your answer. All right, so next one. So what is the sum of the first 6 terms of the geometric series? So you're free to use a calculator for this. Okay, so the first one is 2. Second one is -6. Oh, sorry. So I should say 2, and the second one is -6. Next one is positive 18. Next one is minus negative 54. So you can kind of look at it. So from the first one to the second one, the ratio is -3. Okay, this is a pattern, right? So the next one is always going to be -3. So you can predict the next one. If you use a 54 times 3, it's going to be 162, and it's going to be positive. Okay, we're talking about the first 6 terms, so you're going to have a next one. So next one, you're going to times 3, negative 3, it's going to be negative 486. Okay, you're going to combine all these. So 2 minus 6 plus 18 minus 54 plus 162 minus 486. Okay, so your sum is going to be negative 664. All right, so what's the sum of an infinite geometric series? So you want to use the formula. So S equals to A1 over 1 minus R. Okay, so in order to find out what A1 is, all you need to do is subbing 1 into N, and you should be able to find A1. Okay, so negative 144 times 1 half to the 1 minus 1. So we know that's going to be negative 144. Okay, so A1 is negative 144. The ratio is going to be 1 half. So ratio is 1 half. Okay, so you have negative 144 over 1 minus 1 half. So that's going to be 1 half. So it's going to be negative 144 divided by 1 half. That's going to be negative 288. All right, so what's the sum of infinite geometric series? So we can use the same formula we used earlier. Okay, so in this time, it's going to be a lot easier because we can quickly identify what A1 is. So A sub 1 is negative 3. And then look at the ratio. How do you go from first to the next, the previous term to the next term? Okay, obviously you can look at it, everything is negative. So your ratio, you just have to multiply a positive to continue to get all negative values. All right, so what you're going to do is identify the R. R equals to 1 half. Okay, because you multiply by 1 half, that's how you get to the next term. So R is 1 half. Okay, so S is equal to negative 3 over 1 minus 1 half, so that's 1 half. So S equals to negative 6. All right, so the formula for the sum of infinite geometric series is that. That's the one I talked about. Okay, it may be used to convert to a 0.23, okay, to a fraction. So what's the value of A and R? So you just have to plug it in, okay? Just plug it in and then see which one gives you 0.23. All right, so this one is easy. So 0.4 is basically 4 over 10. This 4 represents, let me use a different color. The second 4 represents 4 over 100. Vice versa, you got 4 over 1,000. The last one, 4 over 10,000. Okay, so pick that one. Okay, so which fraction? This is an easy one. I don't really need to talk about it. Okay, just use a calculator, divide it, and see which one gives you 0.12. That's the beauty of multiple choice for these questions. All right, so I'm gonna tell you guys that these word problems. Come on, man. I've been doing this for the whole entire semester. I'm just gonna give it to you guys, okay? So feel free to pause. Okay, this is another question. There's another question. Just have it, man. Just have it. Okay, so just for once, I just want to take a little break and not explain every single question, okay? I really wish that this is the last lesson of our Algebra 2A in the Ingenuity lessons. Good luck. Hope you guys can keep up and then try your best. And good luck in the future. Thank you very much.